One of the core fundamentals of programming are variables. Variables are used to store information. To declare a variable, we started with a type, followed by its name or identifier, and we set it to some initial value. So the type of this variable is integer, name is age, and the value is 25. There are a lot of data types, and we will introduce some of them. Each data type is characterized by its name, size, and default value. In this table, you can see all primitive data types which are embedded in C# language at the lowest level. We use float for real numbers. Also, we can use double, which has more precision. Also, we have bool type for Boolean logic, which might be true or false. For characters, we use char. And for text, we use string data type. Firstly, we will look at integer data types. They differ mostly whether they are signed or unsigned, and by their byte size. Thus, also by their min and max values and the range they can cope. As you can see, for really small numbers, we can use byte or ubyte, and for really big numbers, we can use long or ulong, whether it is signed or not. We can access max value by typing class of that primitive data type. So we can type int 16, 32 or 64 dot max or min value. Here we have written max value of ulong, which is biggest data type. Real numbers or floating point numbers is data type in C#, which is used to represent numbers with fractional or decimal parts. Float is a 32-bit data type, which we specify with the F. Well, it can be omitted. And double, which we specified with D and has 64 bits. Both float and double data types are designed to handle a wide range of real numbers, including very small and the very large ones. Float and double can take special values, and it is nan, positive infinity, and negative infinity. Nan stands for not a number. We can access those values by typing that class using dot notation and that keyword nan, positive infinity or negative infinity. It is also important to say something about accuracy of float types. Float can store only numbers up to 7 decimal places, and double only up to 15 or 7 or up to 17. So those numbers, when they are stored, they get rounded to the appropriate sizes. Real floating point numbers in C# consist of 3 components, and it is sign, so 1 or -1, mantissa, and oda, also called exponent, and their values are calculated by a complex formula. In calculations with floating types, it is possible to observe strange behavior, because sometimes given real number happens to lose accuracy, as you might see, especially when dealing with numbers that cannot be precisely represented in real floating point format. In the example, you can see that number 0.1 has no accurate representation in floating point numbers. And as you can see, its arithmetic can produce mistakes. Therefore, it is not suitable for precise financial calculations. In addition to these real number data types, C# also provides a type where numbers are represented by the decimal numeral system rather than the binary one. Decimal is often used in financial and monetary calculations. Decimal type is a 16-byte number. It is generally used when exact decimal representation is required. Boolean type is declared with the keyword bool. it might have two possible values, true or false. In this example, we declare two variables of type integer. We compare them and assign the result to the bool variable greater ab and equal a1. And we print those results. Character type is used to store any character from Unicode table. In this example, we initialize one variable of type char, initialize its value with a, grade a, and b, and print the Unicode values of those letters. And do not forget to enclose letters into apostrophes. And we can build our application by pressing Ctrl F5. It works just fine. In this example, we can see string concatenation and printing results in the output. Object is a special type which is the parent of all other types in the .NET framework. It can take values from any other type. It is a reference type, i.e. an index, which stores the actual value. As you can see from the example, we can store the value of any other type in an object. Okay, let's run our application. That is pretty visible. Yeah. Nullable types are specific wrappers around the value types, for example as for integer, double, or bool value, that allow storing data with a null value. Null means that the variable has no value. The example shows how a nullable variable, integer with a question mark, can have a value directly added even if the value is non-nullable. The opposite, however, is not directly possible. For this purpose, the nullable type's property value can be used. It returns the value stored in the nullable type variable or produces an error, namely invalid operation exception, during program execution if the value is missing or null. In order to check whether a variable of nullable type has a value assigned, we can use the property hasValue. It returns true or false. Another useful method is getValueOrDefault, which returns the value, or if it is null, it returns 0. We can see it clearly if we run the application. Nullable types are used often for storing information which is not mandatory. For example, if we have student with first name and last name, which is mandatory, and with age, which is not required, we can use nullable integer as a data type. In C#, we have naming conventions for variables. Names should be descriptive and explain what the variable is used for. In C#, it is generally accepted that variable names should start with a small letter, and every new word, however, starts with a capital letter. Variable names should be neither too long nor too short. Names should not contain underscore or digits if it is not necessary and doesn't clarify code better. Here are some examples of well-named variables, and here we have poorly named variables. As you can see, this first name starts with an underscore, age is all capital letters, A37, its name is not descriptive, and one cannot tell what is the variable used for. And lastly, start index, which starts with a capital letter. When we want to declare a variable, we specify its type, for example, string or integer. We specify its identifier, for example, age, and we can set the variable equal to some initial value. When we want to assign a value to the variable, we type identifier on left side, use equal operator, and we set to some value on the right side. Data types in C# are two types, value and reference. Value types are stored in the program execution stack and directly contain their value. Value types are the primitive numeric types, character type, and the Boolean type. Like for example, those types. Also, we have reference types that keep a reference or address in the program execution stack, and that reference points to the dynamic memory, also called heap, where their value is stored. The reference can only point to objects of the same type, i.e., it is a strongly typed pointer. All reference types can hold a null value. In this example, we will illustrate how value and reference types are represented in memory. Consider execution of the following code. We have declared some variables of integer, char, bool, object, string, and array of bytes. Now we will look what happens if we change values of those variables located in the memory. As you can see, changes of the value type, for example I, age, or result, changes its value directly into the stack. When changing a reference type, things are a little bit different. The value is changed in the heap, and the variable keeps reference unchanged. We have already met with primitive data types, which are special data types built into the C#. We can call them also literals. In C# language, there are several types of literals. As we have mentioned, those are Boolean, integer, real, character, string, and null object. For a Boolean literals, there are only two values, which are true or false. We use those literals for some Boolean or logical operations. Integer literals are sequences of digits. They can contain also sign, like plus or minus, and suffixes and prefixes. With them, we can indicate if it is a hexadecimal value with X, whether it is long type with L, or whether it is uint or ulong with the character U. Real literals are also sequence of digits. They can have a sign, plus or minus, and also suffixes, and also decimal point character. They have also following indications: F for a type float, D for type double, M for a type of decimal, and we can also indicate with E that it is an exponent. For example, we have a power of the -5. Character literals are single characters enclosed in apostrophes. We use them to set the values of type char, and we can express those values with a character, for example, small case A, or using character code. Sometimes it is necessary to work with characters that are not displayed on the keyboard, or with the characters that have special meanings, such as the new line character or tabs, quotation marks, etc. Those characters cannot be written directly in the source code. Thus, we have invented escaping sequences, and one of the most used ones are those for single quote, double quotes, backslash, new line, and offset. And also for a character specified by its Unicode number. Let's look in the example. We have created escaping sequence for character code, for a single quotation, and backslash. When we run the program, we get that result. If you want to have a speech marks in a string, it won't work on its own, because speech marks are considered designated character. This is because quotation mark indicates this is some string and something is not recognized. We want to insert quotation marks inside other quotation marks, and this is when the backslash comes in. So we create a escaping character, and now it is acceptable. We have directory path stored in a string. Let's output it to the screen. Okay, as you might notice, we have here only single black slashes. If we want to undo this and keep the double backslashes, we can use add character, and so this string is called verbatim string or quoted string, and as we can see, those backslashes are being kept. So now we have double backslashes. At the end of each episode, we will have some exercises. Do not skip them. Without them, you will not learn a thing. If you do not practice what you have learned, you risk not learning anything and simply wasting your time. Those are very small and feasible problems. In practice, when you become programmers, you will solve similar problems every day, but on larger and more complex scale. If you have any problems with some exercise, feel free to take a look on a solution or just use a Google. In this episode, we've talked about variables, value and reference types, escaping characters, naming conventions, and verbatim string. If you found this episode useful, do not forget to smash subscribe and hit the like button. Thank you for watching, and I will see you next time.